So this short clip is about cohesion and polarity, but specifically about surface tension and why surface tension actually occurs at the surface of water. In other words, where water meets the air. And so we're coming back to this sketch, which shows the water strider on water because of the description that's written here. The polarity of water causes cohesion. So because each of these has positive regions and negative regions, these molecules all have this attraction to one another. They are attracted to one another along the surface of water, whether it's around a drop or whether it's on the surface of a puddle or the surface of a pond or rain on the windshield of a car. Water molecules tend to stick together and pull inward into a drop. What happens when the water molecules are actually exposed to the air? So, cohesion causes surface tension where water meets the air. So the question that I would ask you to think about is there surface tension below the surface of water? So here's another view of the water strider on the surface of the pond, but with a lot of water molecules down below. And so I would ask you to consider these molecules down here, and I'm going to just mark 3 or 4 of them, and maybe 1 or 2 more. And so here we have a group of, let's say, 9 molecules below the surface. And these molecules are all reaching out with this attraction of polarity to the molecules all around them, and they're binding, or they're attracted, or they're sticking to the molecules all around them. And so they all share a similar level of intermolecular force. Intermolecular meaning inside of a substance where all the molecules are touching one another. However, if we look at some of these molecules on the surface and we observe that some of these molecules on the surface, while they are connected and sticking to one another in a horizontal manner along the surface, and they are sticking to some of the molecules, they're attracted to some of the molecules below them, there are no molecules up above to which these molecules along the surface, right along the surface, these molecules right along the surface, there are no molecules above them to which they can become attracted. So does that have an effect on how tightly or how strong the intramolecular forces are in these molecules at the surface compared with these down below? And so in thinking about the answer to that question, let's take a look at a drop of water. This is a drop of water. And we're just going to kind of zoom in on that molecule that's down below the surface, and we'll zoom in on that molecule that's right at the surface and observe the difference in forces. In this diagram, all of these molecules around this guy right here in the middle, all of the ones around are drawing attraction to that molecule. They're drawing the attraction. They're drawn to that molecule, and they're drawing that molecule to themselves. And remember, this is 3D. So there are some molecules behind here that we're not looking at, and some molecules between us and the screen that we're not looking at, that we can't see. But certainly, just in a 2D sketch, we can see that this molecule has attraction to more molecules. Count them. 1, 2, 3, 4, 5, 6. To more molecules than this one here does. This one is being attracted to 1, 2, 3, 4, and 5 molecules, but nothing up here except air. And water isn't very attracted to air. So the actual surface tension along the surface of a pond actually becomes created because the molecules right along the surface of the pond have greater attraction, greater attractive forces, greater polarity, greater intermolecular forces. All of those words. The forces are greater to the side, to the molecules on either side, and to the molecules just below. because these molecules right along the surface don't have anything to be attracted to up above them. So they're more strongly attracted to the molecules below. And this is the primary function of intramolecular forces that causes this skin or this surface tension along the surface of a pond or along the surface of a puddle or in a glass or in a drop of water clinging to a bush after the rain. So the forces are different on molecules below the surface of water than they are on the surface where the water molecules come in contact with air. So let's summarize. When we think about what's happening at the surface of a pond or at the surface of water or at the surface of a puddle or on the surface of a drop of water, for that matter, the intermolecular forces, the forces between molecules, this polar attraction between molecules, is greater at the surface where the molecules meet the air than down below the surface where one molecule's polarity is shared with many, many more molecules. At the surface, there just aren't as many molecules for each molecule on the surface to be attracted to because the air is above them all. And this is what causes surface tension. Those molecules on the surface actually stick tighter with greater force to the molecules all around them on the side and a little bit below, so that you have this sticky skin or this surface tension, which creates almost a trampoline-like surface for small insects, leaves, paper clips, pieces of paper to be suspended on when in contact with the water molecules at the surface. I hope this helps you understand a little better the details of how surface tension works.